So let's talk about everybody's favorite topic, geodesy and the Jenny Beckhoff effect. Now, if that means nothing to you, that's okay. You're in pretty good company. One of my more unconventional beliefs is that the floods described in the book of Genesis came about not so much from rain itself, but from the earth doing a quick tilt, and from that basically causing a global set of tsunamis which caused the floods which the book describes. And also for reasons that we can go into later, I do wonder if there is a risk of that in the future. Now, getting to all that will take some time to unpack, but for today, I want to go through part of what we can do, or what I and others have been doing on occasion in the meantime, to kind of just check and kind of see what does the Earth's orientation look like. Is there anything anomalous? So the place to go to get this data, or at least one of the preferred places, would be from a JPL website hosted by NASA. The EOP here, too, this is Earth Orientation Parameters. This is basically a mathematical average of sorts of lots of different data sources, from satellites, from atomic clocks, and from other sources that attempt to go and give you a sense for, take the Earth, take the way it's spinning, how fast is it spinning, which way is the pole pointing, how does that orient to the broader galaxy, basically where is Earth in space, which way is the pole pointing, and how fast are we spinning. That's what all this data goes and tells you. And I can probably go and I should probably put together a quick GitHub repo just to kind of put together the script to download this and all that. We'll get to it later. But the couple key things that you'd want to note from here are that, this is being downloaded today as of December 14th, 2025. The last UTPM data point here, that is data on the length of day, or the speed of Earth's rotation, if you will. That's current as of today. The actual orientation data, that gives basically the XY on a plane, if you will, of where the pole is pointing. That has a couple week delay because it takes a while to accumulate the data, do the math, do the averages, and get it updated, if you will. So for what we'll be looking at today, we'll just use kind of this parameter here, which is, or this date here. So we'll go back to December 2nd as being the most current data. So here's a Jupyter notebook. I'll make sure I've got the most current file here. This is the downloaded data from this site here in a Jupyter notebook as of December 14th. Now let's look at a couple different things here. Let's look at the UT sigma versus date. This is essentially the uncertainty in the length of day, or on the exact time of day, based on the Earth's rotation. And if we look at this versus the last 5 years or so of data, the chart doesn't look like much. You can see a little bit of an upward swing here, perhaps, over the past, call it a year or so. Now let's get rid of some of the noise here. Let's take the 50-day mean of the uncertainty, and here you kind of see there is. It makes the trend a bit more clear. Now, on a long-term basis, if you go back very far, let's go back 25 years instead of just 5 years. On a very long-term basis, the uncertainty is actually going down. And the reason for that's pretty simple. We get better measurements, better satellites. We can, with more confidence, look at what's actually going on here. Now, there are a few, spots where the uncertainty does tend to trend up a little bit, so I don't want to overanalyze anything happening this year, because the magnitude of what's going on in 2025 looks to be less than kind of 2008 to 2011 or so. So that gives a bit of context. But if I go back to just the last 5 years or so, there is a bit of an increase here. Or if you look at the bottoms, these troughs here, they do look to be trending upward a little bit. So I don't think this is anything to think too much of yet, but we'll keep an eye on it. If it gets much more exaggerated over the next couple of years or so, then I would be more concerned. For now, I don't think this is anything remarkable. Now let's look at the polar motion data. So this is giving basically a view of where the true North Pole, not the magnetic North Pole, but the true, spinning around it, if you will, North Pole is pointing. And let's again do the last 5 years or so. And here there's something which I think is kind of interesting. The diameter was smaller, and then it kind of got bigger, and then it kind of got smaller again. And that, I believe, is called the Chandler wobble, that it gets bigger and gets smaller. It does seem like it was a pretty abrupt hook here, if you look at the last 2 years or so. Let's just do this. So over the last 2 years, you had this big, kind of more graceful arc, and then things moved into this tighter formation here that, has been there for the last year, maybe year and a half or so. And that looks conspicuous. It looks like it's gotten, smaller more abruptly, but it's actually supposed to get bigger and smaller over time. If you look at where it was, again, over the last 7 years or so, it was smaller, it got bigger, it's gotten smaller again, and there were more anomalous things, like here, I think this is 6-7 years ago, there was a bigger hiccup, if you will. So again, here, nothing looks overly anomalous. Nothing looks concerning. But I want to kind of make an exercise of doing things like this now, today, so that at some point in the future, I've got a degree of comfort looking at the data. And so if things get truly anomalous, I'll have more confidence then to say things look concerning, having had some experience going through and looking at the numbers with some cadence leading up to that. So I hope to do one of these at least once a week or so, maybe every couple of weeks. The data doesn't change that quickly, but it's a practice which I think, at least for me, gives me some comfort, so that I don't get either swayed by headlines saying the sky is falling when it's not, but also if things do become more concerning, I've got a bit of a baseline to work with.